In this video, we are going to look at issues to distribute keys, issues we have in distributing keys and managing keys. Okay, so when we say, bring up. So when we distribute keys, so we have secret keys, for data encryption. That we need to send over from one side to the other. And then we also have public keys. Okay, how do you obtain somebody else's public keys and make sure that public key really belongs to that person? And also how to manage private keys. Okay, so these are the keys we need to distribute and manage. And of course, the private keys are not to be distributed, but we need to manage it. We need to manage private keys. Okay, so first of all, we already saw how to distribute secret keys using PKC, right? So so Alice has a secret key to distribute. So what she does is to use the recipient's public key to encrypt it. Let's say public key for RSA, and then encrypt that key, and then you can then she can send it over to the recipient. The recipient then uses his own private key to decrypt to decrypt the ciphertext to retrieve the secret key for data encryption. And also, we mentioned the time complexity of RSA is superlinear, so it is not meant for encrypting long messages. Okay, so by encrypting short messages such as secret keys are good enough. It's good enough. It's suitable. Okay, it's suitable to encrypt short messages such as secret keys. Okay, so now let's look at the concept of master keys and section keys. Okay, so when you use secret keys to encrypt, when you use secret keys for data encryption, so you don't really want to use one key all the time because, let's say, let me explain this. So let's say a person, Alice, okay, communicate with Bob, okay, and a lot, all right, many times during a day. Oops. Okay, so instead of using one key, okay, each time Alice will use the same key to do encryption. So that, let's say, this is a very long period of time, then this, even though KA is not transmitted over to Bob, right? They only transmit KA once. So Alice only transmits KA once. But then because you use KA to do all encryption, that is equivalent to exposing this particular key to the attacker. So this is not a good practice. Instead, we should use this management of master keys and section keys. The idea here is that for each pair of communicating parties, at the beginning, it generates a master key. Okay, so let's say in each working day, it generates a master key for A and B. So to minimize the expose of KM, then for each section, each communication section, you generate a section key. Okay, so so this master key will be transmitted over via PKC. Right, so this is using PKC. Okay, like RSA, and then for each section key, you're going to transmit it over using the shared master key. Okay, so let's say A to B, right? So this master key is valid for a working day, for instance, and KS is valid only for that particular section. So that may, such as a short conversation or just one email or sending one file. So this is one very short section. So that has a new key. Okay, so this is the concept of master keys and section keys. So the idea of doing so is to minimize the exposure of one secret key, of a single secret key. Okay, so let me remove this. Okay, the other concept is that when we so the other concept is public key certificate, right? So when Alice sends over her secret key, so what she does is to find Bob's public key. So let's say this is Bob's public key, and then encrypt it and send it over to Bob. So now the question is, how do you know KB is really Bob's public key? Right? So how do we know? And so the attacker may fake a website for Bob and posting a public key and lure the user to use it. So we need to make sure that the public key really belongs to whom it said it was. Okay, so the way to do so is the concept of public key certificates. We need a third party to certify that this public key really belongs to Bob. Okay, really is Bob's public key. So this public key certificate authority is a trusted organization For instance, Adobe is one, right? So these are commercial organizations. So we call it public key certificate authority, or simply certificate authority, CAs. So that means for each key, so for each public key, you need CA to certify it is a legitimate public key. So then there's a certificate. In chapter 4, we're gonna talk about how CA can certify a key. So basically, it is just a, so let me just write it here now. So it is equivalent to using RS, well, one way to do so is to sign KU. Let's say this is Alice public key. So this is using RSA to sign it. But then it uses CA's private key to sign it. Okay, so this is a certificate. Of course, plus other information of Alice, right? So let me make that clearer. So maybe Alice. So this is Alice public key, maybe some other information about Alice, right? But basically, it is just a encryption using a private key. So this is called a signature. Okay, so to verify this signature, the CA should have its public key published on its website. So in order to use a particular CA, you need to be a subscriber of that service. So that means you know CA's public key. So to verify Alice public key, you will just need to know that you will just need to decrypt, okay, this certificate. Okay, so just using this public key to decrypt it. For instance, if it's RSA and you use CA's public key because you can obtain this, and then the certificate, then you can get, okay, so this is a certificate. I'm sorry, this is the public key of Alice, right? And then you compare this one with the one that's published on the website or that's sent over. So you compare with the one you got. Compare with the one. So this is posted. That's how you would know a public key certificate really belongs to whom it says it is. Okay. So in chapter 5, we are going to look at a concept called public key infrastructure. So that is how we can set up an infrastructure to create public key and to generate certificates, revoke certificates, that kind of thing. So that's called PKI, public key infrastructure. Right now, we just need to know that to use a public key, we need to have a public key certificate to make sure that public key really belongs to whom it says it is. Okay. So now it comes a issue of CA network. Okay, so we know that there may be multiple CAs, right? And so let me see. There may be multiple CAs. For instance, let's look at this diagram. So here we have two CAs and Alice, so this A is Alice, is a subscriber of CA1, and Bob is a subscriber of CA2. Okay, so that means Alice public key is certified by CA1, and Bob's public key is certified by CA2. So now, if Alice sends her public key, so this is her public key, so we use U to indicate the public key with a certificate. Okay, to Bob. Now, how can Bob verify this is indeed Alice certificate? So that it really requires that CA1 can be certified by CA2. So both CAs need to be able to certify each other. Okay, so that means in addition to sending this to Bob, you should also send the certificate for CA1's public key that's certified by CA2. So which means it needs CA2, and this is a CA1's public key. So it has to be certified by CA2. Likewise, if Bob sends his public key certificate to Alice, it needs to send over a certificate of CA2's public key. So that's how different users of different CAs can certify each other's public key certificates. So let me remove this. And another concept is if you have more than two CAs, okay, so some can authenticate the other or certify the other CAs. So that we create, you can see here, we can create a certification path. So this is just one example. Let's say we have 5 CAs, and Alice is right here, and Bob is right here. Okay, so let's say A wants to communicate with Bob. Okay, and so let's see. So for Alice, she can use the CA5, and then, so that's one authentication route, or she can also use this. Okay, so it's longer, it's shorter. Okay, so then obviously you can see that there are in application which root you want to use, right? So sometimes you want to use the shortest one, but the shortest one, it also involves the mechanisms, okay, built in. So it may not be always the best choice of using the shortest one, but that really depends on the underlying mechanisms used for each CA, such as how they protect their systems, what algorithms they use, that kind of thing. But I just want to bring this up using this slide to indicate if you have more than 2 CAs, then there will be a concept of authentication path. Okay. In the current practice, we don't really need to worry about this yet. Okay. Because the public key infrastructure is not commonly used yet. Okay, it requires a lot of negotiations between CAs. So normally, if you want to certify your certificate public key, you want to certify your public key certificates, you just have to be subscribing to one CA, and for the other person also just need to know that CA's public key to verify. Okay, so that's a simple solution. The next slide is a concept of key rings. So here we are concerned with, we have a public key. Right, so let's say each user, and it has talked about many different people, Charlie, Jane, and so on. So of course, let's say you already got Bob's public key. You already got Charlie's public key and certificate, CA1. All right, so this is a pair. A key and a certificate, so this is CA2 from a different CAs. So this comma, and this is J's public key. This is also CA1. So then you need a store. So you don't want to do the verification each time. So once you verify once, then you don't want to redo the verification. So in this case, you can store all of these information in a one data structure stored. So this should be stored in a data structure. Okay, and that is called a public key ring. All right, for each user, you have a public key ring. For the other people, you have already talked about. And then the other one is called private key ring. So what it really means is that so for your private key, each user can store his private key locally, okay, encrypted using his password, right? So that is one way. So let's just say I have, let's say this Alice. has its private key stored using his password as using his password. Let's call it PA as secret key to encrypt it. So just like a system, so this is Bob, this is Alice, and then Bob has one, right? So Bob has one. Just like a system that stores a password file, the system may also store or encrypted private keys of its users in a data structure. Okay, just like you have a data structure to store that's called password file to store all user passwords. So then that is a concept of private keyring. Okay, so there are other things to go with this keyring, for instance, time, that certificate, right? So for these, you have a certificate. So who certifies it, the expiration time of this particular certificate, the issue date, right? So these are other these are other pieces of information that you may want to store in a keyring. So, and for this, for the private keyring, instead of storing the encrypted private key, you would need to store the corresponding public key, and also because for each public key you need a public key certificate. So the public key certificate for that public key as well. Okay, so that is the topics of key distribution and management. Okay. So stopping here.